Hello, everybody. Whoa, we have someone else joining. Hello. Thank you very much for joining us here today. It's a pleasure to have you here. Well, it's Apoorv's first PyCon, so you're gonna have to be extra nice to him, and I want extra applauses as well. So please, okay? So please, a very nice round of applause for Apoorv Garg with reduce the environmental footprint of your Python programs, please. Very nice.
I can. Can I start? Thank you. Uh, Thank you everyone for joining. So the topic is reduce the environmental footprint of your Python program. So like this topic is a little weird because when we talk about software development, have we ever thought about the environmental impact? Like when we write code, we don't know what's the carbon emission of our code. So the talk is about how to reduce it. So before moving to this, I would like to say, like with the current AI advancement, this has become a concern. I'll show you how and how we can reduce it. So coming to who am I am currently a software developer at Wells Fargo. It's a US investment bank, and I work in India, and so I flow from India. I am an open source maintainer and GSOC mentor at JD Robot, where I have been there for the past 4 years. This year I joined Django as the Google Summer of Code mentor, so a lot of open source contributions there. And I learned Amazon from Amazon experts via a program called Amazon Machine Learning Summer School. I don't know if it's a global program, but it was there in India. I did it in like 3 years back. And then, yes, I do sometimes teach Python virtually to high school students. Oh, yeah, beyond coding, yes, you can talk to about me like food. I love burgers. There's a surprise to that. And I travel a lot. And so travel stories are always good to learn. And yes, I watch a lot of animes. Oh, I am a vegan, so vegan burger only. Now coming to the carbon footprint of Python program, is this really a concern? Like, are we are talking about something to reduce, but is this really a concern? That's what like I would like to know. Like, has anyone here ever considered the carbon footprint of their code? Like, you can raise your hand if you have. Oh wow, I didn't expect that much. Thank you. So the reality is that exactly like software has a very real impact. Like just imagine what we do every day. We go to Google and we search. That generates around zero point 0.2 to zero point 0.7 gram of CO2. I know the number sounds very less, but considering the world population, it will, like it's like billion, and if billion are making one Google search, they will be generating around zero point 0.2 gram of carbon. Now coming with the AI, just training an AI model, can produce as much as carbon as your 5 cars can produce in their whole lifetime. That's like around 500 metric ton of carbon that is producing by just training one AI model. And now we talk about the data centers. We all know, like when there was the Ghibli trend, we saw some tweets from Sam Altman, my GPUs are melting, and all those things. So we can say the data centers account for about 1% of global electricity use. And coming to the Python, Python is an interpreted language, and there are some certain operations that can be more energy intensive than the compiled one. Now, how to measure it, right? We are talking about the concern, but how are you going to measure your carbon footprint code of your Python program? So there are few Python packages, namely Code Carbon. That's the most common one that you can see when you search about the carbon footprint. So it's a Python package that tracks emission from computing. Then there is a website called Green Algorithms. It's an online calculator for environmental impact of your computations. You can put all different type of data, like what's the number of CPUs you are running, where you are running. It depends upon the region also. So it takes all those information and tells you how much carbon is getting emitted and what's the real life impact, like how much planes can be flew in that particular code. So it's a real nice tool. Then we have this carbon tracker, again a tool like for it is for like definitely like for the training of deep learning models. So it's little over the deep learning model side of the carbon tracker one. Then they are energy profilers. If you are running in Google Colab, you will also see they also have this the CPU generation power. So all those energy profilers are inbuilt in some of the notebooks, online notebooks. Now coming to who are the stakeholders, like like who should care about the carbon footprint of the code, right? So I believe it should be like all of us. How I would say, like developers, we can optimize the code efficiency to reduce the carbon footprint. Then we talk about the companies. Companies also have to go for the sustainable practices, and there is one thing called carbon taxes. So that can also be reduced by the code that we are if we are using some techniques that reduces the carbon footprint. Now coming to the cloud providers, as they are the like 1% for the global electricity use, they also become one of the stakeholders. Then definitely the end users experiencing battery drains and the higher cost for it. Then regulatory bodies, we have so many bodies that keeps the check on the carbon emissions, so they are also becoming the stakeholder here. And definitely the future generation who will inherit the environmental consequences if we don't take measures here. So now coming to the benefactors, like what would we say, to the product manager? We want to reduce carbon. He would like, no, I need to, solve the business problem. So how to take it to the stakeholders? So that's one of the concern, like business, again with the all the same things, like as stakeholders we can talk to the benefactors. Then coming to the AI impact, with the AI impact, like I would like to share one fact here. Yes, as we can see, I have highlighted it in purple. Like uh, a Nature's.com study revealed that the carbon footprint of training a single big model, maybe like a GPT-3, is equal to like 300,000 kg of carbon dioxide emission. So this could be quantified as equivalent to 125 round trips between New York and Beijing. So I think that's a lot, 125 flights from New York and Beijing. So this is the emission produced by the AI. Now, there are two things. When we are talking about AI carbon footprint, I was thinking like there is a difference between using and training. Like training is something that a company would like how many big AI models will be getting trained in a month, maybe 3 to 4. So that's not a very big number if we multiply again in comparison to the usage. Like even an individual query can contribute to like 2.5 to 5 gram of CO2 per query. So there's one study that shows like AI generated images emit like 300 to 310 to 2900 times less carbon emission per image than a human creator. So if a human is working on some image creation, he is emitting more than the AI. So there is a use case where we can reduce the carbon emission in comparison to AI. So here is the again a study showing, sorry, which shows like about the AI generating text of one page, where a human from US, from India, how much of the carbon emission is emitted. It's in gram. So we can see the difference. Like AI is definitely useful in reducing the impact itself, but I'm talking about the training and how we can do more better and reduce this number. In the inferences also, like in terms of usage also. So I would be talking about the techniques. That's the main topic. It's going to get a little textual, but I'll try to keep it a little easy. So about efficient data structure, we all have learned data structure in the computer science courses where we are talking about how to minimize the time complexity or the space complexity. So that's when we talk about the efficient data structure, like heap structure might be more useful in some cases, or there's a stack over recursion. So those things we need to take care about. Then we have vectorization using NumPy. Sometimes actually makes your Python program way faster when you are working with NumPy uh, in integers array. Then memoization. This is one of the key topics that we have always seen when we are going for dynamic programming kind of situation. It really reduces the time from 1000 millisecond to 100 millisecond. And then there is efficient input and output operations. We all know that input output operations are the most heavy user based kind of operations, and it does produces a lot of carbon emission. Then generator approach, rather than putting all the things in one go in RAM, we can approach make use of generator, like making some use of batching. And then efficient looping. So these are the this way it's not concerned about the AI only, but you can do it for any Python program. I will be, oh, you please, you can take the photos. I was a little fast, sorry. Now coming to the techniques that comes under the AI area. So I'll just put it out here. We have all these techniques and maybe more. I put my research over these techniques like quantization, pruning, caching, distillation, batching, and flash attention. So we will be covering these today in a little more depth. So coming to quantization, when I talk about quantization, this is like a very boring kind of a like mathematic thing they are talking about using 8-bit integers instead of a 32-bit floating point integer. I'll try to explain you in this manner. We are looking at two pictures here. The first picture is using maybe maybe 100 plus colors. The another image, it's using only 16 color. So that's what, like imagine an AI model as your detailed painting, but here in the quantization you are converting that painting from million of colors to just a few dozen color. It looks nearby it's the same, but taking much less space. You are talking about like 100 colors you are storing in memory, and now you're just taking 16 type of colors in memory. So that's how quantization works. You can see the difference here. Definitely there is a slight drop in accuracy, but we will see how it impacts in the AI. Now in AI, it reduces emission by 23 to 50% according to the strategies applied, and the accuracy is like around 1 to 2%. Speed, definitely. Now I'm talking about the speed. Like if someone asks your AI any prompt or something, how fast it has become. It is producing the it is giving the answer in half the time. And then again, the memory usage is definitely can be seen because we are moving from 32 bits to 8 bits. So there is definitely like four times savings. Now this is the result from TensorFlow library. They have a library called TensorFlow optimization. So you can see in the accuracy, like in the quantized accuracy, there's like 71.06. It's actually got increased even. In some cases it is getting increased, and in some cases it is like 0.2% drop. I think that is good enough if we are getting faster inferences and reduce carbon emission. Oh, sorry. Now coming to another technique called pruning. So to simplify model, we remove unnecessary components. Like if we have heard about binary search tree, we all know like on the left side we have smaller numbers than the root, and on the right side we know that we have higher numbers. So if we are trying to search, you won't be if you know that the number is a little higher than the root, you won't be going to search in the left side of the tree. You would be going directly to the right side. So such techniques can be applied to AI also in neural networks. So like there's three techniques. I will talk about L1 regularization based pruning. So again, this method adds a penalty for complexity during training. Now, if I talk about, like, think of it like a budget where the model learns to focus on what's most important rather than it has, because of the limited resources, it will be learning what's most important rather than learning all the things. So that's how we are pruning the neural network. Then we have the most common one. This is highly used. That is called magnitude pruning. So if I talk about magnitude pruning, if just imagine a tree which has the weakest branch, it actually corresponds barely to the tree's health. So we can remove that branch. So if I talk about mathematically, we remove the smallest weight because in neural network that's going to make the least impact. So least impactful weights going to get removed in the neural network. Then we come again to this one more sophisticated one, like Taylor expansion pruning. The name itself is sophisticated. If I talk about here, what it does, it calculates which branch provides the most fruit before deciding what to prune. Like if we have a branch that we know it is going to give the best result, why prune it? We will go for the other branch. So here if I talk about again in the mathematical terms, it reduces error, it estimates how much error would increase if we remove a component. So it's like in the reverse criteria it would be checking, if I remove this particular branch from my LLM code or from my neural network, how much error it would be bringing in the branch. So it's like a feedback model. So it's a little slow in training, but it does create effect, like not more other than these L1 and magnitude. So it's like a lot of trimming. Now coming to the results of it, again upon it's a like pruning ratio is something that you hyper tune. You put a hyper tuning is like there are some variables we don't know how much effect it would give to our AI models or the LLM models. So sometimes what developer does it, they give some ratios like some metrics, like I will do with 2:1 ratio or maybe 4:1 ratio, and they try to hyper tune it. So according to that, the energy consumption can be changed like by 20 to 60%. Accuracy, in this we'll see a little drop of accuracy because we are actually removing some of the branches. It may impact a little more than the quantization. Definitely the speed would be improving by 3x or like 1.5 depending upon the sparse operations, and then the memory usage would be definitely reduced by 30 to 90% upon, again, upon the pruning ratio. Now caching, we all have seen caching in software development when we want to make less calls to our database, remove database bottlenecks. But caching is something that we can apply over AI also. So there are currently 4 techniques that I came across caching in AI, which is data caching. It's this like similar one as key value pair again, where we will be storing all the data like model predictions and retrieve information for quick access. Like if I'm asking what 2 plus 2 to a LLM, it is giving me 4. Such kind of data would be stored exactly in the AI, and it would be giving us the result quickly, and it won't be making any extra computation. Same as like any caching we do for the databases. Then again comes a different caching, which is prompt caching. As we all know, what input we send to the LLM is not the exact input that LLM takes. It has a prompt inside of it, which is like can be a like prompt template, which was seen earlier also in the previous talk. So such prompt can be also cached, like according to the use case we will be caching the prompt, so it won't be regenerating new prompts according to the user input. Then semantic caching, it's a little different here. When we talk about the semantics, we are talking about the context of query. Like if I am asking 2 plus 2 and I have written numbers like 2 plus 2 in number, but if I am like writing it in words like 2 two plus two, how so such of a context of the query, because the answer would be again 4 only. So such kind of caching is also there in AI. Then come the context caching. It sounds similar to semantics, but there's a different. We are talking about the input tokens here. So it allows saving and reusing pre-computed input tokens. And like it's about like asking different questions about the same media file. If you have shared one document, which is like maybe your resume, so it will be caching the document this time instead of the user input we are sending. So results, I've made the results here. Like it definitely doesn't have any impact on the accuracy, but you can see the energy consumption, speed improvement, and memory usage. Here the memory usage would be up because we are using an external memory, like in memory caching we will be providing. So it increase the memory usage. Now this is a very interesting technique, and it's highly used in in transformer models. Now first I'll try to explain what's the problem. Uh, in the transformer model, attention is a critical operation that allows the model to focus on relevant words. Like we have a sentence, so every word compares with every other word. So it creates a attention matrix which can be very big. So here it grows quadratically when we are working with very big paragraphs. So how this becomes a memory bottleneck is not about the computation it does in the big matrix, but it creates the bottleneck in the actually the transferring of data between different RAM in a GPU. So if I talk about it's like moving data between different memory, it creates the so much computation there. So like if we are talking about cooking, I have a pantry and I want to cook some cake or something, but if I have all the ingredients on the counter, it would be easy for me to cook instead of going every time to the pantry. So this is the logic behind how flash attention works and want to reduce the carbon emission here. And it definitely makes the inferences faster. So the approach is it solves this by working with smaller chunks of data at a time. So when we are when we are talking about baking a cake, you have a lot of like you first you will be making the batter, but you won't be putting the frosting together on the ingredient side because there's a lot of previous work that you need to do. So that type of work would be done initially first, and then you will be coming to the other ingredient. So in it happens in the GPU. Oh, so sorry. Sorry, my cursor went to the other side. Yes. So what it does is this algorithm computes attention in a block that fits in the fastest GPU memory block, that is SRAM. So it would be keeping all the things that you require a lot of the time in the SRAM, and it would be making the attention matrix computation faster. And we are talking about the transfer of data instead of the computing there. These are some of the results that have been seen with flash attention. I have put all the links at the end of the slide from where I have taken the results, and I have done some Google Colab notebooks where I've tried to build models and find out the real results also. I'll show that in a graph. And then we have this distillation. That would be the last topic. The basic concept about distillation is basically there is an expert teacher training a promising student. Now, every time if I was like, there's a very big generic model, and the generic model is doing everything for me. But like, let's talk about GPT. GPT can do everything you can ask to him. But if I make only a model that gives me some legal outputs, like it doesn't do anything else beside, like it won't be doing any mathematical calculations for me. It will be just giving me the knowledge on the basis of the lawyer, like of the lawyer side of things, of the legal side of things. So this is like this process is like distillation, where we create small models and compact models instead of very large generic models. So, and it does and it's not learned from the parent model about what to think, but how to think, like how the parent model was thinking about generating this result, instead of just copying whatever it was, what the teacher was saying. So the process is something like this. First, we train the teacher. We create and train a powerful but resource intensive model. As I told you, like GPT gets trained once a month. So we can have a teacher model called GPT, which is trained and producing a lot of carbon in 1 month. But it might be too large to everyday use. Now what we do is we transfer that knowledge to a smaller model using the process called distillation. And this model would now, we would be now optimizing this student model for every legal use case. So this is how distillation process works. So the results are like this, like and here also accuracy can be a little drop down in the student, but we have seen like it is almost 98% if provided with the correct details. And inferences become faster, like 10x. So that's a like good ratio, like if people can see, like, and there's memory usage by 20x, like it becomes very small. So this is done by me, like I put it on a log scale because I was building very small models, and I was trying to differentiate how different models and how different techniques, if applied and not applied, can create a difference. So it's on the log scale, but you can see like wherever we are applying the techniques, the carbon emission is getting reduced. It's about the emission, and it's in logarithmic scale. So with the caching, the results are very high, and with quantization is also the results are very good. Now I have written something everyone has known, like there's a Zen of Python. So I wrote something, but since we are talking about AI, I would like to present this not just as a word but as songs. So I'll create it as a song. I hope you are able to hear it. Thank you.
Energy efficiency counts. Explicit resource management is better than implicit waste. Simple is greener than complex. Compact models beat overfitted giants. Latent compute should be reused, cache it. Model quantization isn't a shortcut, it's a wisdom. There's beauty in pruning. Batching is better than looping. Avoid repetition of effort. Share, reuse, recycle. Clarity fuels maintainability, which fuels longevity. The CPU, the GPU, and the planet all matter. Optimized for carbon, not just speed. One green way to do it is better than many wasteful ones. If the implementation is hard to scale, it's the wrong abstraction. If it burns too much energy, it's not clever. Readability counts. Energy debugging is real. Low carbon is the high road.
Thank you. So, thank you. This song was produced by like the AI itself, and this AI was created by me, and it produced this song. So it's a little lengthier, like a lot of instrumental is still pending. I won't bore you with that. So again, like we are talking about ignoring green coding, and we were talking about technical debt earlier. I think this is something that we can talk about, like is green coding can lead to technical debt. Definitely we were seeing about reducing of carbon emission, but all the techniques that we were seeing were improving the accuracy of the, like I would not say improving the accuracy, but it was making the inferences way faster than earlier. So yeah, thank you. Thank you. Oh, any questions?
Quick question. Is any of the numbers going to be available somewhere that you presented?
Yes, like I have, there's the slide. I've taken the numbers from all the references I've put, like everything that I've studied for the presentation is all here. So all the links are present here. Like if there's some way I'll share this on the, like I updated my slides on the PyCon chat, like the place maybe if it's available from there. So all the links are here, like the blogs, and I generally used Hugging Face because that's I've been looking at for the resources, so it can be as true as possible.
Thank you.
Yeah, thank you.
Hi, thank you for your talk. At the beginning, you mentioned that like this is a challenge for all of us who are concerned about environment when having like these conversations with managers and leaderships. Um, do you have like a positive experience communicating this to your manager or your leadership when actually they have yeah, consider this as a priority or yeah, something important on the strategy of a solution?
Yes. What I have seen is like whenever we are talking to any manager, so they are the business value they are looking for. So every time I present something, so I was talking about the carbon tax. That is something that organization would be definitely looking to reduce. So how company can be benefited with the techniques that that I talked about would be one good way. Like I did a lot of proof of concept, like with small models, how it is there, and then again if you look at any model we were talking, I talk about 4 parameters like energy consumption and the accuracy impact, because no one wants like AI in their production to hallucinate. So accuracy is also one good thing they will be definitely looking for, and the speed improvement. So like what I did is like I put 4 parameters over there, like how energy consumption and like with this much of reduction in the energy, how the company would get benefit out of it. So all those things are important whenever we are taking to like stakeholders, because at the end they want to work with what good it brings to the company. So every time like I focus more on the like the business value, and then there's one thing they want to know: how much technical debt it required, right? Like how much efforts would be there by the developer if they start working on these techniques. So that is also thing that I show, like this much efforts and like in hours like we would be putting out for this particular technique, and like it would be no loss for for the organization. So those things I generally took to the managers and to the product managers anytime I want to, like even if not green coding anything. Thank you.